Here's the 2019 one. So how did we do on A? Did we know how to write the third degree? Did we get stuck? Could we read the graph?
I would go through all of them.
So what I did is I said, okay, these are the derivatives, and so these are the coefficients, right? Or part of the coefficient for each term. So second derivative, third derivative, fourth derivative, that means that the picture had to give us the function evaluated at 0, and it had to give us the first derivative evaluated at 0. So I could see that the function itself must have been the parabola, and the straight line must have been the derivative of the parabola. And so the parabola was f of 0 equals 3, and then the slope at that point I could tell was going down to right 1. So then over here I basically said, okay, if you look at the first derivative, you get -2. If you look at the original function itself, you have 3. That's basically what I said. Okay, so what I did is I wrote out 3 and then minus 2x and then 3x squared over 2 factorial and then -23 over 2x to the third over 3 factorial. So I just used those to write out those first few terms. Okay. And then after I wrote it out, I went ahead and simplified it.
Can we correct this?
Yeah. Yeah, I can go ahead and correct it. Yeah.
Did Wolf die? Wolf has corona. Who's ready to study for the AP test online? Because we won't be able to come to school.
Next, we have, they asked us to figure out what e to the x times f of x is. And since e to the x is a polynomial and f of x is a polynomial, that means foiling. So what I did, because it says a second degree polynomial, I knew that at the most I needed an exponent of 2. I didn't need anything bigger than 2. So what I did is I took these 3 terms. I did not use the x cubed term because that's too big. I took these 3 terms and I took those 3 terms and I went ahead and I foiled them. I just used a box to do it. So this is me foiling. I just used a box. Yeah.
Do you have to foil them, or could you just leave them as is in multiplication?
I think you have to foil them. Because if you leave them as is, you're not excluding the ones that are bigger than 2. If you just write the parentheses, that would be including stuff that's bigger than 2, and it would no longer be a second degree. It would be an incorrect third degree because you didn't consider the other x cubed term. So it would not be right. Yeah, you'd have to foil them. So, yeah, so I have these 3 times these 3. And when I foiled it, you can see here, these boxes that I x'd out were things that had an exponent that was too high. And so when I foiled them, I got those answers, but I did not use them because they were bigger than a second degree. Yeah?
Wait, in the foil part, what happens to the 23x?
I didn't use it because it's x cubed, and they only wanted a second degree, so they only wanted x squared. So I left it out because I already knew it was too big. Okay, so when I foiled those, I got 3 plus x squared. Thank goodness that was nice. Okay, then they said let h of x be the integral from 0 to x of f of t dt. And so what I did is I took my answer from part A, and I wrote it in terms of t because they said f of t dt, so I wrote it in terms of t. And then I went ahead and I just did my integration. So 3t. After that, you just switch it out for x. Yeah. Yeah. Yep. So I wrote the terms out, all of them in terms of t. I went ahead and I did my integration rule right here. And then I said it was evaluated from 0 to x. And so basically at that point, you just take the t's and switch them out for x's and subtract 0 off the end. It's possible, you really should do that step, like think through it, because if they had a constant there somewhere, it would make a difference. So just be careful about that. So here's my h of x. And then I said, okay, h of x, if I plug 1 in, and this is the point where if you wanted to not simplify it that you could. If you simplify it, you get 97 over 48. But you don't have to simplify it. Yeah, you could leave it. Well, the thing is, if you forget, if you're like in the process of simplifying it and you feel uncomfortable, You don't have to erase, just scribble it out. Just like put an X through it. They can't grade it if it has an X through it. So if I were to get down here, in theory, what I should do is I should go, okay, that's interesting, and then I should X all of that out. Because this is the most conservative thing for me to do. If I know they're going to grade it, I'd rather get the points than accidentally make a mistake and get the whole thing wrong. Okay. We good with that part? Okay. This one said alternating series error bound. We're not good with that part? We are good?
Not deep.
Okay, so what we did, what I had to do is figure out what the next term was. And so what I did is I took the information from the table, because it says in the problem that you're using from h of 1, and h of 1 was to the 4th, right? And that was based off everything we had up at the table until the 3rd derivative. Does that make sense? So that means I have to go back and take the next one to be able to get my error from. So I looked at the table. I said 54x to the 4th over 4 factorial. We're comfortable with that? And then I wrote it as 54 over 24. 54 over 24, those are both divisible by 6. And so I called that 9/4. And then what I did is, because since we were doing our error in terms of h of x, and h of x had been integrated to get that function, I then took that term and I integrated it. And when I integrated it, it made it into the 5th exponent, which is why it fits to be the 5th, because the last one was the 4th. Are we tracking? That part was kind of weird. So then I have it to the 5th, and then I'll go ahead and say the error is less than this term evaluated at 1. And when I evaluated it at 1, I got 9 over 20, which is less than or equal to 0.45. Yeah.
So what part of that is from C?
The part of it that's from, you didn't take an answer from C, you took your understanding of C to know what you had to do. So I knew that the terms that I had here were from the table up to the 3rd derivative. So that meant if I wanted the next term, I had to use the 4th derivative to get the next term. Then I had to say, okay, in C, I integrated the terms to get the function. So then I had to take my next term and I had to integrate it so that it would be correct. So that's how part C played into part D, even though technically I didn't use any of the answers from C to do D. Okay. All right. Any more questions on that one? So this was the actual FRQ that students took last year. They had that for real. Okay. All right. Did you guys get to see, did you look at the answer key last night, I'm assuming, when you were trying to figure stuff out, so you already kind of know how the grading worked? Okay. Do I need to talk about that at all, or does that make sense?
I looked at D and even
Wait, for the first one where it says 2 terms, is that you have to say
So
f
the
of 0 equals 3 and f prime is 0 equals -2 at the top?
no, the 2 terms are saying, see how there's 4 terms total? First 2 terms is 1 point, second 2 terms is the other point. So this is not getting any credit at all.
Oh, so as long as you have that.
Okay. 3 terms for e to the x, and then isn't it ridiculous that that whole foiling process is only worth 1 point? That's so much work for 1 point. Notice this one gives you a point for the antiderivative. Do you see how it's in terms of t? It's not in terms of x yet. So be careful for that, because I could see a lot of us just going straight to x's, because it was x in the original problem. And then 1 point for the answer once you have the x and you plugged the 1 in. And see here also that we have like this is them kind of showing like they would have taken this as an answer, and then all the steps up to this is the final answer. So either one of those would get full credit. Okay. And then for our error bound, they use the 4th degree term, so we wrote that down. Uses the first omitted term of the series for h of 1, which was us doing the 9/20 t to the 5th, getting that the error bound is 0.45. Okay, 2018. All right. So for this one, they told you what ln of 1 plus x was. So when they say that you're writing the first four non-zero terms for f, and they're telling you that f is x multiplied by ln of 1 plus x over 3, what that means is you're taking this function, you're plugging in x over 3, 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 and then you're going to take that whole group and stick an x in the front and distribute that x out. So here is me kind of showing my work with that, x in the front, and then x over 3s in all those spots. And I had x over 3, but I distributed the x, so x squared over 3 squared, which was a 2, so I had the 3 squared and the 2 both on the bottom. And then I distributed the x, that's how I got x to the third. Then this was x to the third with another x is the x to the fourth, 3 to the third on the bottom, and then another 3 on the bottom. X to the fourth with another x is the x to the fifth, 3 to the fourth on the bottom, 4 on the bottom. Yeah.
Do you have to,
344.
you can just write the thing on the bottom.
You can just write this.
Okay.
You don't have to show your work. Okay.
Wow.
So I have,
'Cause I forgot.
now be careful about this, your general term. So it was x to the n to start with, but we have the x also going to the general term, so that's where I got x to the n plus 1 from. And then 3 to the n on the bottom and an n on the bottom. Yeah.
Why does the negative 1 have an n plus 1?
I think because it had it in the original problem.
Oh, so they're starting at 1 instead of...
They're starting at 1 instead of 0. Yeah.
If you keep it as x over 3 to the n,
You're fine. You should be fine. Yeah. All right. So here I went ahead and we're doing the interval of convergence, and so I did the ratio test. Do I need to talk through any part of that? How did we do on the ratio test?
Ratio test was fine.
So it did not include, so the radius was 3, and the interval did not include negative 3. It did include positive 3.
oh, I did not.
Oh, yeah.
So you have
Oh.
to do the center.
So
You don't have to do the center and radius when I'm so used to doing all 3. You just had to do this.
Okay.
How many points do you lose if you don't do the interval correctly?
That's a good question. We'll see in a second. Okay. Any questions on any step of that? We're okay with reducing things? So right here where there's an x, I just plugged the negative 3 in to check negative 3, and then right there I plugged a 3 in to check positive 3. So whenever I have a negative number with an exponent, I always separate the negative from the number. So I had negative 3 to the n plus 1, so I rewrote that as negative 1 to the n plus 1, and then 3 to the n plus 1. And then I have the same base with exponents, so I combined those bases together, and I added the exponents. So I had negative 1, and then to the 2n plus 2. 2n plus 2, no matter what you plug in, is an even number, and that gets rid of the negative. The negative completely goes away at that point. So we're left with 3 to the n plus 1, and then 3 to the n, and then n. So what I did then is I took the 3 to the n plus 1, and I separated it. 3 to the n, 3 to the 1. So it's kind of like, it's like the pieces of the ratio test where you're simplifying things. It's kind of like that. So then my 3 to the n's canceled, and that left a 3 on the top and an n on the bottom, right? Because my negative was gone, and that's a harmonic p-series. So I knew that that diverged, which is why over here in my interval I put a parenthesis, not a bracket.
So divergence.
Because it's not including, right? If it diverges, I don't include it in convergence. And then over here, when I checked the 3, the negative 1 was going to stay in the problem then, because I didn't have a negative to pull out from the other one. So I did the same thing I did with the first one, where I took the n plus 1 and I separated it. 3 to the n, 3 to the 1. The 3 to the n's canceled, and that left me with 3 to the 1. And then because I still had the negative 1, I did the alternating series test. And so I saw, oh, this is going to go to 0, and then, oh, the next term is less than the term before it. And so that would be converging. And that's why I had a bracket. Okay. All right, so for the next problem, it said we're plugging in 2, and it said that we were using the 4th degree. That make sense? fourth degree. So that means that what term am I going to use for my error?
The fifth.
The fifth, that one that has an exponent of 5. All right, so what I did is I wrote out, did you have to find the, I found the approximation, but you don't have to. That was me just doing extra work. So I said the fourth term with 2 plugged in minus the function evaluated at 2, and then I wrote, you can write error, and I wrote out x to the 5th over 3 to the 4th times 4. So that was me just writing out the term that it would have been. And then I just went ahead and plugged 2 in, and then I went, why would I do the math when I don't need to? And so I didn't. So I left it.
I did the math as well.
8 over 81.
Yeah. It is 8 over 81. That was right. Okay. So for the first one, you get 1 point for the first 4 terms, 1 point for the general term. This is what I was talking about, where saying the setup for the ratio test was important because you get a point for that, and then you don't get any more points until the end. So that setup is important because that's an easy point to get, right? If you don't even know how to do the ratio test, at least get it started. So setting it up and then getting the limit of the ratio, that having the absolute value of x over 3. And then knowing that the x over 3 is less than 1 for your convergence and multiplying the 3 over and figuring out that the radius is 3, that's another point. Okay. After that, considering both endpoints, so the work that I did to consider -3, the work that I did to consider 3, and then the analysis and interval. So that means if you considered the endpoints and you did it wrong, you still get the point for considering them. Does that make sense? And then you get 1 point for actually getting it right.
Is this just how these types of problems are standardly graded?
I have noticed that it seems like, oh look, they allow you to do it a different way too. That's interesting. I have noticed that it seems like they have favorite things, where it's like if you guys noticed when we did the differential equations and there were the separation of variables problems, those were all graded very consistently. It was like always, did you separate the variables? Did you get the antiderivative? Did you have the constant? Did you have the plus c in there? Did you solve for the plus c? Did you isolate y at the end? They were like always worth 5 points, and it was the same 5 points every time. So my guess is that these are the same way, is that these have like the same like point breakdown for each of them probably. Okay, so the next one uses the 5th degree term as the error bound and then the answer. So, all right, how are our brains? Do you want to take time now to do another FRQ, or do you guys want to do multiple choice for a bit and do FRQ later on in the period?
The latter.
The latter.
Okay, so let's get started with some multiple choice. You guys have the assignment from yesterday. We're looking at the 2004 FRQ. Okay, so we have not looked at one like this. There was one in the packet, but you guys, I didn't make you do it for the Lagrange error bound. So when it's got a plus sign, you can't just use a Maclaurin and plug in all the stuff inside because that's not really how trig works. So you could get your green sheet out. We are not going to do it that way because I'm going to assume you're not going to remember that formula. But on your green sheet, there is a formula that talks about if you're adding 2 different things inside, how you could rewrite the problem. And it's, I can't remember the one for sine.
It's sine first thing, cosine second thing.
Yeah,
plus or minus cosine.
So it would be sine 5x times cos pi fourths plus cos 5x times sine pi fourths. But you wouldn't remember that, so we're not going to do it that way, okay? So that means since this, just remember what you have to remember basically is if it's a 5x, if it's sine of 5x, use the Maclaurin, plug in 5x, you're good. If it says plus, throw away Maclaurin, do it by hand, okay? So we're going to go ahead and say if I want to find p of x, and that's the 3rd degree Taylor polynomial, then that means that I need the function and the first 3 derivatives. So function.
Is it always first 3?
It's whatever the degree is, that's how many derivatives you need.
Oh, I didn't even pay attention to that.
Okay, so we've got sine of 5x plus pi fourths And then what's the derivative of that?
Cosine of 5x plus pi fourths times 5.
Okay, and then we got that times 5 because of the chain rule.
Negative 5 cosine per pi.
And then negative sine goes to
Negative cosine.
negative cos.
And it's negative 125.
Okay. And then what do we have to do from there? Evaluate it. So we're plugging in, what's the center?
0.
0. Okay, so we've got sine of 5 times 0, that's just 0, plus pi fourths. So sine of pi fourths is root 2 over 2. 5 times cos of pi fourths
Also,
is 5 root 2 over 2. Okay. Okay, go ahead and take a minute to finish doing those.
In this case, is it better to write it as its actual value, like evaluated value?
I don't think it matters.
I mean,
You might see if it matters. You might see if it matters later on. There might be a point where you start to realize it matters.
Well, I mean, leaving it in the unevaluated form does make it slightly.
You can kind of see the pattern.
See the pattern for like.
Mm-hmm. Yeah, and part B says we're going to look for the x to the 22nd term, and so that pattern will be nicer than actually multiplying 5 that many times. Okay, so now that you've got the numbers, go ahead and take a moment to write out the polynomial.
Would there be a subscript for this? So
You can use one. The reason I didn't is because they did not use that in their notation for A. They just said P of X. No. No, I've noticed they are pretty forgiving when you mess up variables, especially in a case like this where you're not even messing up a variable, just using a subscript or not. Are we good with writing that polynomial out? How are we going to know what the 22nd derivative would be without actually doing it? Yeah.
Well, first off, you see where it falls into the 4-step thing.
Does this one go to that one afterwards?
Yeah.
Kind of, okay. Because negative cos would go back to positive sine. Okay, so what do we do with that?
Modular 4.
Yeah, that's, you check it and you see, hey, where does this fall? So you first, you like, hey, it goes through 5 times, and that gives you 1, then you go down to, that would be negative sign, I believe.
That sounded complicated. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22.
Yeah.
There.
Oh, that was simple.
And then
That was
it's
simple.
5
Okay.
to the 20.
So the 22nd derivative would be negative 5 to the 22 sine of 5x plus. Okay. So that's the 22nd derivative. They want the coefficient of that term. So go ahead and take a moment. Make sure that we know that the coefficient has, you know, some more pieces to it. Think about how the terms are made. I got my answer wrong when I did this one because I didn't think about how the terms were made.
Why isn't that over?
So this is just the derivative. I'm not done yet. I'm just giving you guys a hint to get started. But you still have to do the rest.
Should we guess?
Don't say it yet. We got people who are going to think for a little bit. Figure it out. If you feel like you're done with that one, go ahead and do the next one.
Christina thought she was going to say it. Go ahead.
Go ahead and walk out to the parking lot and die. I'm just kidding. I'm just kidding.
Don't die in this class right now. I'll be back.
I think I'm recording right now.
Good
Hi,
thing
Elena.
there's a bunch of eyewitnesses. Who testified.
Soon we'll all have the Atlanta experience.
Maybe.
Oh, yeah.
North Carolina's in a state of emergency.
Well, that's only
No
for
school.
funds. That's only for
Federal
funds.
assistance.
Yeah.
Doesn't mean we're not in a state of emergency.
Okay. So if we evaluate this at 0, we're going to get negative 5 to the 22nd times root 2 over 2, right? And if we were to put the term together, we would say negative 5 to the 22nd root 2 x to the 22nd over 2 times 22 factorial. So if we want the coefficient, sorry, that was 22. If we want the coefficient, we just get rid of this, and then that's the coefficient. Okay. C.
I just read the general term. So
Yeah,
and
that's
then
fine.
I just took out the x. Is that cool?
Yeah.
With your negative 5 to the 22, I was questioning where the factorial is. Which I guess you're done for.
This factorial?
What?
All right. Part C. So I'm going to go ahead and just write down my work for Lagrange. How far did the P go for part A? What exponent did we get to? 3. Okay, so I'm going to say max of f to the 4th derivative on the interval from what to what? 0 to 1/10 times x to the 4th over 4 factorial Okay, so real quick, I'm going to say the 4th derivative would be, so 3rd is down here, so 4th is back to the top. It'd be 5 to the 4th sine of 5x plus pi fourths. And when we don't have a graph to reference, do you guys remember what I said we could do for a sine or a cosine graph?
Estimated at 1.
Estimated at 1. You guys remember that? Because it bounces between 1 and negative 1. So if we don't know what the decimal is, let's just use 1. That's the most conservative thing we could do. So I'm going to say that the derivative is going to equal 5 to the 4th times 1. That's the most conservative thing I can do there. Does that make sense? Okay.
So 5 to the 4th times x to the 4th, or 4!
That was very aggressive.
And then what are we plugging in for x?
110.
1/10.
Is it 1/10? Because that's the upper bound.
It's 1/10 because that's what you're evaluating it as.
Yeah.
Mm-hmm. Okay, and that is less than 1/100th. And if you want to simplify that, you can. You do not have to. I would maybe recommend leaving it.
1/24,000th times 5 to the 4th.
Yeah, you can simplify it way down, which I did, but you can do that later. We're gonna leave it here.
625 over.
But this would be an acceptable answer.
That would be an acceptable answer.
And now I'm out of room.
Okay. So for D, it says g of x is 0 to x f of t dt. They want a third degree polynomial for g. So if they want g to be a third degree, then what are we going to take from the f of x part? The second, because then when we do the integral, then we'll get a third. So for D, we're going to do the integral from 0 to x, and we're going to take our function, but we're only going to go up to the second power. Now, with the notation, it said f of t dt, so we're going to put it in terms of t. So I'm going to write root 2 over 2 plus 5 root 2t over 2 minus 5 squared root 2t squared over 2 times 2 factorial dt. Now, we are not going to skip straight to putting the x in. Why not?
Because you need to integrate first.
Because if they give us a point for an integral, or for having the antiderivative, we want that point for the antiderivative. Okay? And the antiderivative does not have x in it yet. It is in terms of t, it's being evaluated. Okay? So, I'm going to say what?
Root 2 over 2t plus 5 root 2t squared over 4 minus 25 root 2t cubed.
So that right there is probably a point. And then we'll plug it in with the x's. Oh, this was a plus. I missed my plus. And then we'll minus off what we get when we plug in 0, which is 0.
0.
Okay.
We 5 minus 0 is?
That's not minus 0. We're in Babylonian math. There is no 0. That's the big brain way to think about math. There is no 0 means it doesn't exist.
Okay.
That's it?
That's it.
It's simple, but when I'm doing it, it's going to be me panicking.
Can this just be the FRQ on the test?
No. All right. What's another FRQ we should look at while we have time?
2011.
2011?
I said it right in here, I'm not sure if we have one. So,
There is a 2011.
oh.
I don't know. We're just going to start some together.
The 2011 one does look confusing.
Yeah, sure. Okay. 2011. Is it because of the crazy graph? Okay.
Partially, yeah.
Write the first 4 non-zero terms of the Taylor series for sine. Okay, go ahead and do that. You guys know that.
Yes.
Ow.
There's the 3, 4. There's 4.
You guys, we didn't even take 15 minutes on that one. We did it in less than 15 minutes.
And we worked together, so it was slower than usual. Or, I suppose, faster.
Faster. Definitely faster.
Toby, not all of us are like you.
Okay.
Well, yeah, but I do it fast but wrong, so I don't know.
Which one is the sine one?
It's odd.
It's odd.
Okay, so x.
X minus x cubed over 3 plus x to the 5th over 5 plus x to the 7th over 7.
That was not annoying at all.
It was also incorrect.
Okay.
We didn't say
Then write the first 4 non-zero terms for sine of x squared. So go ahead and do that. Fight.
Steven, do you want to kill a wolf?
He killed the wolf.
Why would you kill
The
a
boy who
wolf?
cried wolf.
He made a mathematical joke.
Mathematical jokes are fine.
Miss Rice made it the first day we were talking about the day you weren't here. So you don't get the joke, so you don't have the right to get mad at him about it.
Like wolves at the slaughter. It makes her laugh.
No.
That's a lot of X's. August has a
Finally.
jinx.
What?
Our Mr. Best is very terrible about grading work, and he just returned
I'm sending him this video.
a month and a half old essay.
Oh, so he knows them.
Oh,
Yeah.
He's very lenient when it comes to extensions because he knows he doesn't.
It nearly took him 3 months to grade a short story.
Yeah, because they weren't that important.
Alright, so next we have cos, and we're writing the first 4 terms for that.
We don't have to simplify it to make the 2 and a 3 a 6.
Yeah. I mean, actually, I would do it because it is going to help.
Too much to multiply a 2 and a 3?
Rewrite everything again.
I just didn't write it in the first place.
So cos is
Even 1
minus x squared over
2 plus x to the
x
4th over
4.
4.
okay, so next they want us to take the answer for A and what we just wrote for B, and they want us to use that to write f of x. What does f of x say?
Sine of x squared plus cos.
Okay, so what they want us to do is add these two together. Okay.
That's terrible.
It could be worse. So we're adding these two together. And they say when we add it together, only write the first 4 terms. We don't have to write everything, just the first 4. So 1 is the first term, that's pretty easy. Then we have 1x squared and negative 1/2 x squared.
So 1/2 x squared.
1/2. Okay. Then we have x to the 4th. That's the next one. And then we have these fractions I'm not going to figure out. So I'm just going to write negative 1 over 3 factorial minus 1 over 6 factorial. Do you see that clever math I'm doing? You guys see how I did that? That's shortcut for, I don't feel like adding those, and I'm not wrong. I combined my like terms. That's a coefficient.
Oh, you could do it like that?
Yeah, that's 1/6 minus 1/24.
You just have the x on the top and then do the things on the bottom.
Probably. Yeah.
I'm gonna not do it that way in case you can't.
But notice I wasn't trying to be tricky with my signs. I just wrote plus and then I said they're both negative, so I left them there. So I'm not trying to be tricky. I just am leaving it. I'm keeping it, making it easiest for myself. Okay, we have 4 terms. Do we need the x to the 10th and the x to the 14th?
Nope.
We do not. Okay, so we combined our like terms. We have all our coefficients there. One of our coefficients looks weird, but we're cool with it. That one's done.
Oh! We can, oh, wait, no, we can't. It's
Okay.
a corner. Dang it, I was gonna say we could use the graph, but we can't. It's a corner.
Yeah, okay, so find the value of the 6th derivative. Do you guys remember how we do this?
Just do
Just do the derivative 6 times.
Nope.
Can you just use the pattern?
Use the pattern.
So you have,
Well, I guess do the derivative a couple times.
it's, you take that function and you go, this becomes negative 1 times positive.
No,
Yeah, but
I
we
wouldn't use the
need-
pattern that
No,
way.
'cause we need.
Think about how the terms were constructed. So throw this problem away in your mind. How do terms get constructed? So they are whatever you get for the derivative, right? So we would say the 6th derivative evaluated at 0 times what? It's centered at 0
Times x to 12.
times x to the 6th. So the exponents, they got to match. So I'm throwing away the problem. I'm throwing away the problem.
Over 6 factorial.
Over 6 factorial. This is how we would construct the terms, right? Okay. So I'm going to get rid of this. This equals this coefficient. Because that's the coefficient they got. So this equals that. Does that make sense?
6 factorial.
So negative 1 over, I don't need parentheses. Negative 1 over 3 factorial minus 1 over 6 factorial somehow equals this.
Oh, just that one.
So I thought about how was that term created. I thought about that. It's always the derivative times x to the 6th over 6 factorial. It's only x to the 6th because it's centered at 0. If it had been centered at something else, we would have had a parenthesis there.
It's 726. It's over 726.
So what I'm going to do is I'm going to multiply the 6 factorial to the other side, right? Because that's going to isolate my derivative. See that?
And then you can get cancel.
Yeah. So I've got negative 6 factorial over 3 factorial minus
That's 120.
6 factorial over 6 factorial.
1.
So that's 1.
119.
Can somebody tell me what 6 factorial is? Like, how do I multiply it? 6 times 5 times 4 times 3 times 2 times 1. So this cancels with this. 6 times 5 times 4. 120. So I've got negative 120 minus 1. Negative 121.
Oh, it's negative, not positive. So I big it.
Yeah. But in theory, you could have left it like this. Right?
I would not.
That would have made me very sad.
But this is something that has shown up in assignments in a few different spots, is us figuring out what that coefficient is. So all you have to do is write out the term, like the formula of how you would have made that term, and set it equal to the coefficient. Yeah, this is a funky problem. The simplifying of this problem is terrible. Yeah. Yes.
How would you know that it's the coefficients from the previous step?
It's not the coefficients from the previous
It's
step.
the coefficient of the same
They said 6th derivative, so I looked at the 6th exponent.
Because that's the 6th
Yeah,
time.
but I'm talking about like when you're looking at the answer from part B. How would you know that last? What's its name?
6 and 6, they match.
I'm still confused how you would get that in the first place. Like, how would you get the coefficient for that in the first place?
So I said 6th derivative times x to the 6 over 6 factorial.
No, for part B.
This coefficient?
Yeah.
I just said the number in front of x to the 6th and the number in front of x to the 6th, and I'm combining them. Like if it had been like 5 and 7, 5 plus 7 is 12, but it's like funky numbers. Okay. Let's jump down to the error bound so we can at least set it up. So D, we have the error, I'm going to go ahead and just say error, is less than or equal to the max of, now what they said some notation in here, so what are we going to use? Fifth derivative on, what's our interval? 0 to 1/4. Okay, times, how do we construct that term? So this is the derivative.
The fifth derivative evaluated.
And then what else do I have? Times x to the 5th over 5 factorial. Okay. Now, this is when I... 0 to 1/4. So I'm using the center and I'm using the 1/4 because that's what they're plugging in. Now, when I look at the graph, this is the fifth derivative. This is the graph of the fifth derivative. I'm looking from 0 to 1/4. I'm ignoring everything else. Where on that interval is it the highest value?
At 1/4.
At 1/4. What is the highest value? I'm going to go with 40. It looks to me like it could be 30. 40 is a conservative estimate. It is definitely less than 40. Do you guys see that? I don't know if you can go, it's above 20. It's for sure above 20. 30 would be like, oh, you might be calling it close. 40 is like, yep, you did a great job calling a conservative estimate. Okay? So I'm going to say that my error is less than or equal to 40 times, what do I put in for x? 1/4, because that's what we're approximating. To the 5th over 5 factorial.
If you put 30, would they count that wrong?
I don't think so. I think they'd be okay with that. If you did 20, they'd count it wrong. If you did 25, they'd count it wrong. I think 30 is cutting it pretty close. I think 40 is a good conservative estimate. I think $1 billion is probably too big.
What about 35?
Will they accept 8?
I don't know.
What about 35?
Yeah. And this has to be less than 1 over 3,000. That might be the kicker, is that 80 might have boosted it, so it's not less than that. Yeah. All right, and then if you wanted to simplify that, you could.
But you could just leave it.
But you could just leave it.
Thank you for all the help. Oh, I did like barely any.